Okay, welcome everyone. My name is Yus, I'm from Indonesia. Welcome to my channel, and today I want to explain for you in this video how to implementing the projects of LQR control to your robotic system. And the first one, before you starting your programming and before you start to choose before you starting your programming and before you start to choose the best methods and how to implementing the code, how to define the libraries and the system of ROS, first you must create the design thinking problem solving for your system. And this is really important because this is really useful and helpful for you to solve the problem, any of problem in robotic system. The first one, you must define the problem here. So you must explain your problem, declaration, description, and what is the point that you want to solve. And then after your problem declaration, there are solution lists, the solution and all of the steps that you must follow to fight back the problem. And the solution will break down to the implementation of the segmented tasks and will execute in each of this part. And after that, you can make a trial of your system, and you may have a problem, have an error, troubleshoot, and you can go back to the solution list and you can go back to the breakdown task implementation for solving each of the error and troubleshoot each of the part that still have a problem. And after your trial is success, you can finish the project. Okay, that's the simple explanation of design thinking. And first, this is the example if you want to implementing the LQR in your system. So first, you must know the problem. So the first problem, the example is we want to control the robot for efficient input signal and more accurate through simple controller. This is the problem. Efficient input signal and high accurate or more accurate through simple controller. And for this problem we have a solution. What is the proper method that we want to choose as a simple controller that can solve the efficient input signal and accurate of the state? So we choose LQR here. LQR as the method that solve this problem, and we must know how to implementing the LQR step by step until the project will success. And the first step for LQR, we must know the state space model of the robotic system. So you must know the linear algebra for this, because you must create a dynamical model of your system of robotics using state space model, and you need the output state and input. And also for LQR, you need the penalty values for giving your input penalty and state penalty, which is the Q and R matrices. Okay, and the next list of your solution, the next step for implementing this matrix state space, you need to create the library for your program, yeah, the custom library. However, if you can define the existing library in the GitHub or in the any of repository that you have, it's also very useful for implementation. But if you cannot find the existing library, you must to create the library. And the next step, the third step, is calculation of P matrices K and U. U is an input, yeah. So the calculation of the matrix, yeah. So I give any of I will add the matrices here. And then the fourth step, after you define the library and you have performed the calculation of the matrix, the first step is you must including the library in your node implementation, right? So in the fourth step, the next step, yeah, after you create the custom library, install it in your ROS2 node. And after you create the ROS2 node, run the simulation system, yeah, and get visualization and information from your simulation system. And sorry, this is wrong, yeah. So this is the 5th step and this is the 6th step, because you must configure your ROS system first and run the simulation after this. Okay, yeah, this is the correct one. Run your simulation and get visualization and information. And the next step, you can record the data and making analysis based on it. And if all of the steps finish, the last step, create the proper documentation. Yeah. So this is the solution list that you can follow. Yeah, for instance, if you choose the proper method, the LQR method. And of course, all of the methods that you have for any of problem is different, and the step also different. Okay, so make sure about the method is correct and the step for implementation also correct. Okay, after you list the solution, yeah, you can break down the task implementation segment by segment based from your solution list. So this is the example or the system of LQR. This is the task implementation. So what are criteria which must we know from this first step? Yeah, for LQR: state space, state output input, penalty. So penalty is Q and R matrices with sample value. Yeah, so we can define or declare the default of value of Q and R matrices. And the next one is second step, it's making the library. So yeah, how to implement the operation matrices, creating the library of C++ for linear algebra, yeah, in your system. So first you can use the agent lib library, std vector, and also creating the library through HPP file, yeah, and also CPP file for the custom lib. Yeah. So the details about it we can see later, yeah, for our script in C++ code later for the details, yeah. And after that, after the calculation matrices, yeah, the third step we must follow this. What are the details for define the input value for LQR controllers? Yeah, so how to calculate the matrices P, K, and input. Yeah, from the theoretical we know that for getting the P we must follow the Riccati algebra, and after that we can get the value of k for gain, and after we getting the k value, we can know how the system input, proper of system input, the exact value of the input. And after that, the next step is the ROS2 node implementation. After we know how to calculate the matrices, and the next steps or the next task implementation is to reconstruct the ROS2 node for this LQR system. So we create the ROS2 node for the LQR system. So what we need is the first, we need the information from the ODOM. So get the position data. And to implementing the navigation system, the motion planning, the movement of the robot, we need to publish the velocity as a publisher. Velocity using CMD file, topics to publish the velocity of your robot. And you must know the waypoint declaration, so you must know the point that the robot must follow for your analysis later. And the calculation of the error, of course, and also import the controller for your robotics. I mean the import the controller, this is using LQR, so we must know how to import the custom library of our LQR to the node and remain the robustness of performing all of the tasks. So we must make sure that the robot still robust for every points that we have declared here. So this is really important, because if the robot is not robust, it can be difficult for the robot to follow the trajectory and to analyze the controller. And the next step is ROS system configuration. So this is really important for you to analyze the CMake list here. So I think this is not in order, so I will put it before the simulation implementation. So we make sure the ROS system configuration here, list of all of the packages, custom library, target directory executable installed, and we can run the simulation system and get visualization and information. So here, how to demonstrate a simple implementation in robotics navigation. For the simple one, you can use the Turtlebot 3 simulation in empty world, and also RVs for the visualization, and then the RQT GUI for obtain any of information from the dynamical behavior. So this is a powerful tools that you can use to analyze the information. And after all is finished, you can record the data here. It's a 7-step record data and analysis using ROSBAC or using TensorBoard and RQT GUI. After all is finished, you can document, make a documentation on your GitHub, your Medium, etc. Or your personal website maybe. It will really powerful. Okay, that is the example of the first design thinking steps. Problem declaration, solution list, and task implementation. And after that, you can try, and try your system to be run, trial, and you can find the error after that. This is really a few of software engineers that can just in the first trial, it will be a successful all of the step of the system. This is rarely happens. So you must know how to troubleshoot after that, and you will find some of errors, either in the first step or the last step or maybe in the middle step. So you can go to the solution list, yeah, check the error, and after that you can also go to the breakdown of implementation. You can check the error, so make sure your solution list is true and correct here. And after that you can go to task implementation and make sure all of the task implementation is going on the track. And after that you can finish the project after all of the error can be solved, yeah, and finish the project, and yes, you can be a successful of engineer in this project. Okay, thank you very much. That is the simple explanation for design thinking. After this I will explain more for each of the steps and try to make a program for this system.